All right, so as you can see, we're going to spend today working on scientific notation. It's the last set of notes for this unit. It's also a major topic on your unit test, so it would be pretty important that you're following along and diving into this stuff. Not only how to write numbers using scientific notation or take numbers written in scientific notation and change them back, but also how to work with scientific notation and do some different operations with scientific notation. In the notes today, we'll talk about multiplying and dividing, and down the road, we'll also talk about adding and subtracting, which is a little more difficult. But so just to give you an idea of scientific notation is really used when writing numbers that are extremely big or extremely small. We're looking at numbers that are bigger than what we're used to working with or smaller than what we're used to working with. It's not as valuable nowadays thanks to calculators and those kind of things. But at the same time, we still do see it every now and then. The reason it comes to scientific notation is because that's an area where you actually see very large or very small numbers, whether you're talking about microorganisms and the size of cells and those kind of things, or whether you're talking about the distance between planets in the solar system and the galaxy, where you see very large distances. So that's where the scientific notation idea comes from. It says a number is written in scientific notation if it has the form of c times 10 to the n. So if we're just looking for scientific notation in general, scientific notation looks like some number times 10 to some power. So the c and the n are the numbers that we are going to change. Now, what's really important for you to recognize is that c has to be fitting into this range right here. So notice the way I would read this if I broke this into two different inequalities. It says 1 is less than or equal to c. If I change that, that c is greater than or equal to 1. So one thing that you want to recognize is c has to be greater than or equal to 1. It has to be 1 or bigger. At the same time, it says c is less than 10. So it falls somewhere in that range where it's greater than or equal to 1, but it's actually less than 10. It can be 1, it cannot be 10. At the same time, it says n is a blank, and n has to be an integer. Remember, integers are the whole numbers and their opposites. So you're talking about -2, -1, 0, 1, 2, on to infinity in both directions. Either one of those is what we're looking at when we're talking about integers. So let's talk about scientific notation and actually how to write using it. So it says, write the number in scientific notation, and I have 22,000. Not an extremely large number, but a number that we know we could use scientific notation to represent. Over here in the box, it says numbers that are greater than 1. Numbers that are greater than 1, bigger whole numbers, these larger numbers, they will have positive exponents because the decimal must move to the right. So what happens here, what I want to look at when I'm doing scientific notation, is I want to find a number. I want to change 22,000 to fit this description right here that we talked about. 1 is less than or equal to c, which is less than 10. So all I'm going to do is identify where the decimal is right now in 22,000, and then I'm going to move it to fit that description. So what I mean by that is there's a decimal at the end of 22,000. I think we understand that. If I had to have a decimal there, it's at the end of 22,000. I'm going to move this decimal as many places as I need to get it in between 1 and 10. So what I mean is if I move it to the left, now instead of 22,000, I have 2,200 or 2,200. Still not less than 10, so I move it again. Well, now I'm at 220, getting smaller, but not less than 10. I'm at 22, very close to less than 10, in between that range there, but not quite yet. When I move it again, you'll notice if I put the decimal right there, I would actually have the number 2 and 2/10. Well, that fits that restriction that we had. It's greater than or equal to 1, but it's less than 10. So I'm going to change 22,000 to 2.2. Now the issue becomes my number, my answer has to be the same as 22,000. So how do I get 2.2 to be the same thing as 22,000? Well, all I'm going to do is multiply it by a power of 10. You remember from back in the day in 5th and 6th grade, what I want to do is I want to multiply by a number to move the decimal back. Well, the first way you might think of it is if I was going to backtrack, if I was going to go back from where 2.2 is, I want to move it once, twice, 3 times, 4 times. I want to move it 4 times. Well, what you remember is, okay, then I need that many zeros. So 2.2 times 10,000. 2.2 times 10,000 would get me 22,000. If I took 2.2 times 10,000, I would get 22,000. But using scientific notation, that's actually not the way we write it. What we're going to do is we're going to use a power of 10. We're going to use a shortcut using rules of exponents. So I'm going to take this times 10 to what power is the same thing as 10,000. So two ways to think about it. The one way is, well, yeah, I need 4 zeros. That tells me that I'm going to have a power of 4 in my exponent. The other way to think about it is what it says up here where it's talking about moving the decimal to the right. All I ask myself is how many places do I need to move the decimal to the right? So go back here again, I need to move it once, twice, 3 times, 4 times. That tells me 2.2 times 10 to the fourth. So same idea here, maybe a faster example, but the idea is, man, I got a really big number here, 1,317,000. I start with where the decimal would be. and then I move it to where I get between 1 and 10. So notice the biggest mistake that some kids make is maybe they get to here and then they stop. 13.17. Well, guys, that's still not less than 10, so I have to actually go all the way to here. So notice my decimal is going to come after the 1. Everything here that's still a number has to stay. So my C value, my number that I'm going to multiply by a power of 10, is 1.317. 1.317. Then I'm going to take it times 10 to some power, and now I'm asking myself again, well, how many times do I need to move the decimal back to the right to get where I was? 1, 2, 3, 4, 5, 6. Okay, if I've got to move it 6 times, then it's going to be 1.317 times 10 to the 6th. To check this, all I ever have to do is actually follow that through, and you'll see this on our later examples. But if I have 1.317 times 10 to the 6th, that tells me that I would move the decimal 6 places to the right. So I go 1, 2, 3, 4, 5, 6. I know I have to put zeros in here, and so I would have 1.317.000, and hey, look at that. That's 1,317,000. So it tells me my answer was correct. Now, a little differently when we're looking at smaller numbers. So here you see 45 ten thousandths, 0.0045. Well, now again, if you look at the box, it says numbers that are less than 1 will have negative exponents because now the decimal has to move to the left. And this is where the negative exponents lessons that we did in lesson 7 would really help you here. But everything basically works the same initially. So I want you to think about the idea of moving the decimal to get it to that same restriction where C is in between 1 and 10. So now I already see the decimal. It's right here. I'm going to move it as many places as I need to get a number between 1 and 10. So like notice I'm moving this one to the right actually to begin with. This would be 0.45. That's not going to work for me. But if I move it right there, I have 4.5. But notice 4.5 is bigger than my original number, so I need this number to get smaller. And so to do this, I would actually have to multiply by a number less than 1. I'm going to have to multiply by a fraction. And in this case, I actually need to move it 3 places. I would actually multiply this by 1/1000th, because really what happens here is I'd take 4.5 divided by 1,000. And remember, when we divide by a power of 10, just like we talked about earlier, it's just going to move the decimal. And in this case, it's going to move it 3 places to the left. So I'd move it 3 places to the left, and I'd have 0.0045. Okay, so that's the idea behind this. But now we're going to use scientific notation. So remember, it's going to be times 10 to some power, and that power is going to be an integer. To make this smaller, then, I write 4.5 times 10 to a negative power. I want to have the decimal move back that many spaces. So now I go back to my original work and I think, okay, if I have a decimal right here in between the 4 and the 5, I need to move it once, twice, 3 times. I need to move it 3 zeros worth, right? So it's 4.5 times 10, not to the third, but to the negative third, because 4.5 times 10 to the negative third is the same thing as 4.5 times 10 to the 1,000th. So that's more of an explanation on why scientific notation works. To actually get the right answer, don't overthink it. That's truthfully what we're going to do here. We're just going to move the decimal to get it in between 1 and 10. So 1, 2, 3, 4, 5. Notice 0.7 does not work. It has to be greater than or equal to 1. So I move it 6 spaces there. It gives me 7 times 10 to what power? Well, remember, this is a very small number, so it's going to have a negative exponent. I need to move the decimal back to the left, and so I ask myself, well, how many times do I need to move it back to the left? Let's see, what was that again? 1, 2, 3, 4, 5, 6. You have the 5 zeros plus 1 more. You need to move it 6 times, so that's 7 times 10 to the negative 6th power. Just the key is that you have a negative exponent. Writing the number in standard form then should actually be the simpler task here. If I have 4.2 times 10 to the 6th, notice what I see is I see a positive exponent, 10 to the 6th. I actually know 10 to the 6th is a 1 with 6 zeros after it. So if I'm going to take 4.2 times a million, I know I'm going to get a pretty big number. Okay, so now the idea is, well, how do I actually get that answer? Well, I'm going to take my 4.2, and like we talked about earlier, this positive 6 means move the decimal 6 places to the right. So I go 1, 2, 3, 4, 5, 6. Or what I think is I had to move it once, and then that tells me I'm going to need 5 zeros in here. So I'm going to write my answer as 4, 2, and then I have 5 zeros. And now what's very important for you to get full credit on your quizzes and your tests and those kind of things is this is not my answer. Go back and clean it up. Remember, we put a comma every 3 from the right to the left. So I count 3 zeros and I put a comma. I count 3 spaces and I put a comma. And you'll notice if I take 4.2 times a million, I get 4,200,000 or 4.2 million, which makes sense to me. This is a little different because we have a negative exponent, so I see 1.15, and I know I'm actually going to make a smaller number. It's going to move to the left 5 spaces, so start with what I have, move it once, and then I know I still have 4 more spaces to go, which means I'm going to need 4 zeros right here. If you don't understand that, you can actually count this out. I'd have 1, 2, 3, 4, 5. But notice that tells me I'm going to have 4 zeros here before the 1, 1, 5. So the mistake here that a lot of people make again is, okay, I have 4 zeros, and then I have 1, 1, 5, and they're thinking, well, this is my answer. Well, no, of course, guys, remember I moved the decimal to right here, so I need a decimal right here. This is also not your answer. Again, like I said with the commas, you got to clean this up. I need a 0 in front of the decimal. So I get 0.0000115, and you can see what I mean when we say a very small number. That's a tough decimal number to read out loud with the place values because it's so small. Two examples of what you're going to have to do on the second assignment and what you're going to have to do on the test next week. But it says to find the product, write your answer using scientific notation. What I would really draw your attention to is the fact that we have background knowledge on this. It says use your BK, multiply the coefficients, and add the exponents. This is no different than actually what we did in the very first lesson of exponent rules. So what I mean by that is I want you to think of these examples. When I have 1.5 times 10 to the negative fourth times 5 times 10 to the sixth, what I really want you to think of is maybe this is 1.5 x to the negative fourth times 5x to the sixth. If you can think back to those examples where we had coefficients, we had a base that was the same, and then we had exponents. This is no different. I have a coefficient of 1.5 and 5. I have a base that's the same, x in my example here in the green, but really our base that's the same in our truthful example here is 10. That's the same base. So remember what we've said, we're going to keep the base the same, and then we are going to add the exponents. We're going to add the exponents here. So the first thing I have to do is multiply the coefficients. So I say, okay, I have 1.5 times 5. I have to multiply the coefficients, and 5 times 5 gives me 25. I carry the 2, and then I have 7, and of course I have one decimal place, so it's 7.5. When I multiply the coefficients, I get 7.5, which is good because it's in scientific notation right now. I have a number that's in between 1 and 10. 7.5 times 10. Remember, we're going to keep the base the same, and then all I have to do is add these exponents. Well, negative 4 plus 6 is 2, and so it turns out I have 7.5 times 10 squared. I know a lot of kids try to make those problems into standard form and then do the multiplication. Trust me, it's a lot easier to look at it this way. Multiply the coefficients and add the exponents if we're doing multiplication like it says here where it says to find the product. Last example for multiplying, and we'll do some dividing and adding and subtracting later in the week, but it says find the product. Be sure your answer is written in scientific notation, and I would say, knowing this example, that you're going to want to probably pay attention to that idea. So remember what we said before, we're going to multiply our coefficients. We have 2 times 6, we multiply the coefficients, 2 times 6 is 12. We keep the base the same, and then we add the exponents. So I have 12 times 10 to the ninth. A lot of kids would circle this and move on and think, yeah, I'm really getting the hang of this, but I want you to notice that this answer is not written in scientific notation. Remember, the rules of scientific notation say that C has to be in between 1 and 10, right? It can be greater than or equal to 1, but it has to be less than 10. This right here is not less than 10, so I actually have to do a little manipulation here. Instead of having 12, what I'm going to have to do is I'm going to have to take this decimal that's on 12, and I'm going to have to actually move it back. I'm going to have to make this 1.2. Now, what kids struggle with is reasoning their way through, well, what should my new answer be then? I moved it from 12 to 1.2. So I want you to think about what my answer was initially. My answer initially was 12 times 10 to the ninth, which means from right here, the decimal is going to move 9 places to the right. 12 times 10 to the ninth means there's a decimal at the end of 12. It's going to move to the right 9 places. Well, now notice I've actually moved it to the left one. I have 1.2, so now it's got to move an extra space. If you think about it, I moved it back away 1. That's going to mean it's got to move an extra space to the right. So now instead of 12 times 10 to the ninth, I would have 1.2 times 10 to the 10th. I've got to make sure that I wrote that answer in scientific notation. We'll talk about some other ways to kind of look through that and make sure that your answers are written in scientific notation and how to change it. But these notes should definitely take you through assignment 1 in your OneNote notebook, and then as we get to working on assignment 2 tomorrow, we'll get a little practice together and I'll help explain a little more. But there's your quick recap and your quick explanation of scientific notation. Good luck.